Hi everyone. In the last session, we discussed about the parameter parsing techniques. How many techniques we have seen? The first one is call by value and second one is call by reference. And we discussed that so whatever the changes that are done in the called function will not cause any effect to the calling function that is in the call by value. Whereas in the call by reference, so if you do some modifications in the called function, those modifications will reflect in the calling function. So what do you mean by calling function and what do you mean by called function? So main is the calling function and the swap function is called called function. After the execution of the called function, the control must return back to the calling function, right? So we have seen the examples by using C programs in yesterday's class. So in today's class, I will give in detail what is the main difference between the call by value and call by reference with the diagrammatical view. After that, we go for the concept of recursion. So let us go to the details. Right. Now, here I'm going to talk about first one, call by value. So here just I'm going to take the variables AB of the main and the variables AB of the swap. Now I'm taking the values here A and B. A value we have taken 10 and B value is 20. The address of A is 100, the address of B is 200. Assume that. So this we are talking about main. Now so main is calling the function swap by passing A value and B value, right? Next, here I'm talking about the function swap, here integer A and integer B, right? Now in this case, here I'm going to talk about the variables A and B, right? A and B. Now in the main, we are calling which function swap. The control is passed to the swap. Now A and B values are how much here? 10 and 20. Now every location is having its own address. Assume that the address is 300, the address is 400. Now these AB values belongs to this swap and these AB belongs to this main. Okay. Now in the swap function we have done some modifications, right? We have interchanged the values by using the variable temp. So what happened after interchanging the values? The value of A becomes 20, the value of B becomes 10. Now, which values we have changed? The AB values of the swap. This is called function, right? In the called function, we have printed the values of A comma B. I said that printf the values of A and B in swap. Then we got the values 20, 10 here. After executing this called function, we have returned back to the main. Okay, we have returned back to the main. So in the main, before calling swap, we have printed the values of A and B. What is the output we got? We got 10 and 20. After that, we have called the swap function and we have entered into the called function. Here we have done some modifications. Here the AB values are changed only in the swap. These changes will not cause any effect after returning to the swap. After returning back to the swap of the main, here we have printed that the values of A comma B after swapping. We have printed here. Again, we got the values only 10, 20. We didn't get 20, 10. Why? Because the changes is only up to this called function. Those changes will not cause any effect to the variables of main. Why? Because A, B of main are different, A, B of swap are different, right? Here these values will not be changed as this is about the call by value in clear, right? After this, next we are going for another example that is call by reference. In call by reference, again same. Here we have taking two variables. Here we are going to talk about the main. Here I'm going to talk about the swap. I'm not writing everything, just I'm writing in rough. So this is A value and this is B value here. Take 10 and 20 and assume that address is 100, address is 200. Now in swap what we have taken is we have taken integer star A comma star B. These indicates pointer variables, right? So here you take a variable A and this is B. So in the previous case, these AB are the ordinary parameters, but here in the call by reference, these AB are the pointers. So pointer stores address, right? In the main, what we have done is we have called the function swap by passing addresses, right? Ampersand A and ampersand B, we said, right? Now, so what is the address of A here? 100. 100 is passed to whom? A. Here it is 100. What is the address of B? 200. It is stored in the B, right? So these A, B are the pointers which are also have their own address. Assume that 300 and 400. Now, in this swap function, in the called function, we have interchanged the values. How? We said that temp equals to star A. Temp equals to star A. Assume that this is the temp variable. Now, when you say temp equals to star A, what does it mean? A means star of 100, right? So value at 100, value at 100 indirectly. What is the value at 100? So here star of A indicates this value. See here, when we use the concept of pointers here A and B, these indirectly pointing to the ABs of the main. Whenever you say star A, means by using the pointer concept, we are indirectly pointing to this A. Now temp equals star A means here, what is the value of temp? 10. Next, we said that star A equals to star B. Now star A means this location. Here we said star B. Star B means 20. So this is changed to 20. See, by using the pointers, we are changing the values of A, B which are in the main. Next, if you say star B equals to temp, what happened? Temp value 10 and here it is replaced with 10, right? So if you observe this concept, A, B of main are nothing but 10, 20. Now, when you use star A, star B in the swap, also refers to the same memory locations A, B. Please remember, when you use the concept of call by reference, we are pointing to the same memory locations. But indirectly, we are changing the values of A, B by using pointers. So that is the main difference. So here what happened? So whenever you do these modifications, indirectly the values of A, B are also get changed. So this is the main difference between the call by value and call by reference. Now after this, now we are moving to another important concept, that is recursion. What is recursion? See here, now we will see the concept of recursion. Actually, in the previous classes, we have discussed about the looping. Looping is nothing but the iteration. So whatever you have done with the iteration concept is also done with the help of the recursion. The recursion is very, very important concept in functions. So what actually mean by the recursion? A process of, or you can say the process of calling a function, the process of calling a function by itself. This is a simple definition. Calling a function by itself is called the recursion. Okay. Now, what are the good examples of the recursion? The main examples we are going to discuss about is factorial of a given number. Factorial of a given number. After that, the second example we will discuss is finding the Fibonacci number. Finding the nth Fibonacci number. These are the two important examples I'm going to discuss. So many examples are there. So first we will discuss factorial of a given number. Next, finding the nth Fibonacci number. See, the same two programs also can be written by using the concept of looping or iteration. So just now I said that whatever you do with the help of the iteration is also done by the recursion. Then what is the advantage of using the recursion? The advantage of the recursion is it increases the speed of the program. The execution speed is very high if you use the concept of the recursion. And the coding is very less in the case of recursion. Now we will see how to find the factorial of a given number using recursion with example. After that, we will see Fibonacci number. See, for the factorial of a given number, so generally what we are going to do is, while writing the program, first the execution of the C program starts from the main, and the main is going to call the function called factorial, right? It is going to call the function factorial, and factorial is going to take some input n, and factorial is again going to call itself, right? Again it is going to call itself. This is the meaning. So first, the execution of the factorial is started by calling the factorial from the main. Main is calling factorial and factorial is calling itself repeatedly. Okay. See, at some point we have to break this looping. So we are executing the same factorial function more than one time. So at some point we have to break this. So for that we are going to use the concept of the base condition. Base condition, or we call it as the exit condition. If there is no exit condition, we are going to get infinite looping or infinite loop. Repetition is called loop, right? So for that, we have to use the base condition. So let us see the examples. Now, for example, I want to find out the factorial of n. The factorial of n is given by, the principle by mathematics n into n minus 1 factorial. This is the mathematical principle. Here, we are not going to use this factorial symbol. Why? Because we are not using the concept of mathematics. So instead of writing like this, what I'm going to do is, I'm going to use the function, user-defined function factorial. Now, instead of writing like this, I'm writing factorial of n equals to n into factorial of n minus 1. N into factorial of n minus 1. Now, in the program execution, what we are going to do is, first the execution starts from the main. Okay, now the main is going to call factorial, right? Factorial, and this factorial is going to use the concept of the statement. This factorial is going to use the concept that n into factorial of n minus 1. See, the factorial is going to call the same function again. So this is the concept called the recursion. Okay. Now, for example, assume that main is calling factorial. Okay, factorial, right, with some input n. Now this is going to call itself like this. What is this? N into factorial of n minus 1, right? Now this part I'm going to take only this part, right? It is again written as n into again n minus 1. So here this again n into fact of n minus 1. Again this part is divided into n into fact of n minus 1 and so on until we get the base condition. Okay. Now I will give the example like this. Main is going to call the factorial, and I'm giving the input as 5. We know that factorial of 5 is 120. How it executed? So main is calling factorial. The factorial is going to evaluate like this: 5 into factorial of how much? N minus 1 means 4. Now you see, if you observe, this is factorial 4. So already we are in factorial. Factorial is again calling factorial itself. Now this is evaluated as factorial of 4, factorial of n. In this case, n is 4. Now it is denoted as what is the 4 into fact of 3, factorial of 3. Now this part again divided into 3 into factorial of 2, and this part is again divided into 2 into factorial of 1. Okay. Now this is we know the factorial of 1 is, or you can say this is divided into, we can say 1 into factorial of 0. So whenever you get 0 or 1, so assume that whenever you get 0, then the known value for this is 1. This is the base condition. This is the exit condition. Why? Because 0 factorial is 1. So factorial of 0 is replaced by the known value 1. Okay, this is the deadline or dead end or exit condition. So whenever you get the exit condition, then you have to return back. While returning back, what you are going to do is, so you multiply the values 1 into 1, how much? 1 in place of fact 1, we got 1 on return. Next, 2 into 1. How much 2? That we are going to get here on return 2. 3 into 2, 6. That we are going to get at this place 6. 4 into 6, how much? 24. That we are going to get here. 5 into 24, how much? That we are going to get here. This is on return. How much? We are going to get 120. From this factorial, again we are returning back to the main, and in the main we are going to print the value factorial 120. So this is a way of executing the factorial of a given number using recursion. I think it is understood. So in the next class, we will see the Fibonacci number, how to find out nth Fibonacci number. After that, we will implement the C programs using recursion. So with this, I'm going to close the session. The next concept we will see in the next class. Thank you for watching.